Good morning and good afternoon, everyone, wherever you are. My name is Rajkumar, Director of Research at ARC Advisory Group India Office. Delighted to welcome you all to this ARC Asia Industry webinar on making LLMs work on the factory floor from knowledge retrieval to agentic workflows by Mr. Michael Thavarajah, Principal Engineer at Intel Corporation. So today's brief agenda is like this. After me, my colleague Bob Gill, who is the General Manager, Southeast Asia ARC Advisory Group, will be doing a topic introduction. Right after that, we'll have our guest speaker, Michael Tabaraza, Principal Engineer, Intel Corporation, will be presenting on the topic. Then we'll have a panel discussion between Bob Gill and Michael. And right after that, we'll open up for the audience Q&A. And I request all the delegates to put your questions in the Q&A box. And now I request my colleague Bob Gill to do the topic introduction. Over to you, Bob.
All right, thank you, Rajkumar, for that introduction. And a warm welcome from me also to the second ARC Asia Industry Web Insights webinar of 2026. So I know there's many of you who have attended previous ARC Asia webinars, and you will know this is not the first time we're actually covering the topic of AI in manufacturing. Indeed, last year, you may recall that we had two speakers from the automotive and the electronics industries talking about their experiences and benefits of using AI technology in their shop floor applications. But these were similar to the vast majority of the deployments of AI in manufacturing until very recently, which focused on using machine learning to provide enhanced insights from structured data, like sensor readings, like machine logs, in order to enable initiatives like predictive maintenance and process optimization, and also energy tracking and optimization as well. But really, since generative AI burst onto the scene just over 3 years ago, AI, as I'm sure you would know, has taken a great leap forward. And in this context, it's able to unlock value not just from data, but also from unstructured information that you find in manufacturing, like work instructions and maintenance logs, quality reports, and also, I think crucially, records of institutional know-how. And that's with large language models, LLMs, being trained on this type of existing content and able to generate brand new content that can then be queried through a natural language interface and operationalized in real time. So what that means, I think, is that manufacturing is entering, if I can say, a new phase of digital transformation where intelligence is not just limited to dashboards, rules engines, or that type of traditional analytics. Instead, increasingly, we see that LLMs are starting to reshape how manufacturers can capture knowledge, make decisions, and interact with complex operations at scale. And I think it's also very timely because it's against a backdrop of industry trends like operational complexity, supply chain reconfigurations, and shortages of skills and expertise that organizations are using LLM-powered solutions to empower their frontline workers, as well as engineers, planners, managers, with fast and much easier access to enterprise knowledge and systems. And as a result, helping to achieve key manufacturing performance objectives like productivity, quality, and asset uptime. So with that brief introduction to the topic, and to expand and extend this theme of large language models in manufacturing, let's head up north from here in Singapore to Penang Island in Malaysia, to welcome today's guest speaker. As you would have heard, Michael Thavarajah, who's Principal Engineer at Intel Corporation. And really happy to ask him to deliver today's presentation, which is making LLMs work on the factory floor from knowledge retrieval to agentic workflows. So, Michael, over to you for your presentation. Thank you.
All right, thank you, Bob, and thank you, Rajkumar, as well for the introduction. Screen. All right, let's get started here. So my perspective on the presentation today is really that so a lot of us have been using these large language models, and we have experienced personal productivity improvement out of using this application. But making it work from a personal capacity to that of a manufacturing application, something that is scalable and reproducible, that brings value to the manufacturing floor, are really two different animals. And we need to figure out the best way to make this technology work for us as manufacturers. So in today's presentation, I'll try to attempt to kind of give us some ideas, right, on how myself and Intel Foundry has applied this technology in ways that you could also try to reproduce as other manufacturers. All right, so let's take a look at some numbers first before we begin, right? So what we are observing today is that there is a big gap between generative AI experimentation and really production scaled value. The numbers show that we have nearly a quarter of manufacturers have actually attempted generative AI, right? It's in their smart manufacturing solutions or initiatives, but very few have actually deployed it at scale. So there's a lot, the question kind of arises here, which is how do we convert this excitement that we see around generative AI into real measurable manufacturing outcomes? Right. So now, before we kind of go into the gist of the presentation, let's take a step back, right? So let's look at where this technology kind of resides within this whole domain of artificial intelligence. So by now, probably most of you realize that generative AI is all about creating content, right, based on learned patterns, right? And large language models resides within this technology of generative AIs. Now, large language models are basically trained on enormous amounts of publicly available data, right? So we're talking about billions of parameters. And what this enables it to do is really understand and generate human-like language, right? And we have all used the tools, we've seen the outcomes. And now the question really remains, how do we convert those tools to make it usable for manufacturing? So when I speak to engineers or technicians within Intel Foundry, so usually the questions that come up from them is, hey, could I use this technology to answer some of these questions, right? These specific things that we require in order to become a more efficient manufacturer. Things like figuring out which product line is most at risk, explaining yield anomalies, specific directions, right? How do you align tools to specific tolerances, or even writing a shift report, right? So that's when we come up with these specific use cases, we realize that using the technology out of the box as is provides some limitations, right? So these three usually arises as three items that we need to overcome in order to successfully gain the most value out of this technology. So in today's presentation, we'll kind of go through these three limiters, right? And what we can really do about it, such that we will be able to deploy some scaled solutions to manufacturing. Now, the first one here is about domain-specific language, right? So LLMs need domain knowledge if it's going to be truly useful. And it may not have that right out of the box, right? And the risk there is of hallucination. So we'll talk about that first. Next is about latency, constraints, and IP security. And finally, how do we extend the use cases of these LLMs, not just from conversational abilities as chatbots, right? But to real applications that interact with our production systems. So let's go through these three one at a time now. Let's go with the first one, right? So now, when you use a foundational LLM, so like I said, they are trained on immense amount of data. They have immense general knowledge. That said, they are not sufficiently trained when it comes to knowledge of the manufacturing industry specifically, right? So in that case, there is a very high risk of hallucinations. And the definition for hallucinations are basically this tendency to fabricate responses when it's tasked with something that it's unfamiliar with. Now, in other industries, fabrication or hallucinations may not be as impactful, but in manufacturing, it can cause us severe downtimes or defects or even hazardous work conditions, right? So this is a challenge that we need to overcome. And the way to overcome this is really to optimize these foundational LLMs. Right. So let's talk about optimizing, right? For when it comes to manufacturing, there's really three ways that you could go about it. The first is about fine-tuning, right? So fine-tuning is really adjusting a model's internal parameters, right? The weights within the model, so that you could kind of inject manufacturing domain-specific data within it. Now, the advantage of this is that once you fine-tune a model, it really understands manufacturing, right? It understands the facts, the tones, the nuances that we use within our manufacturing context. But to do this, you really need to have a lot of data, and you need to have the ability to retrain a model. That means expertise in terms of people and also computing resources, right? So it's quite a heavy burden to do a major fine-tune of a model. The easier method, which a lot of us do, is really just prompting, right? So we prompt a foundational model with some context, right? So within the prompt itself. So this is the most straightforward method. You solve that knowledge cutoff problem. There's no upfront investment for training, but you just have this very limited context window, right? And if you, like me, in manufacturing, have these really thick manuals that describe every step of our process or equipment and tools, just dumping in the entire manual with every prompt is not going to be very economical and scalable. Now, the method that we have seen the most success in most of the applications that we have is really using retrieval-augmented generation, which is a more specialized information storage and retrieval mechanism, right? And its goal is to provide very context-specific references to the LLM. So it handles that whole vast amounts of data, picks and chooses the right amount of data to pass on to the LLMs, so that we have a very bounded query, right? So this reduces hallucinations, improves accuracy tremendously. You don't have to go through the training costs. And the only minus here is that your knowledge base needs to be up to date. Now, I'll show you a bit more detail on how RAGs function, right? So if we query a foundational model with this very specific question, right? That is specific to a particular tool or operation within your factory floor, you may get a response that is either too generic or irrelevant, right? It could even be a hallucinated response that is going to cause you a problem if the person that asked this question were to implement its advice. So what we need to do as part of an RAG system is basically compile our knowledge base, right? These are the facts. These are the content that our factory uses, and embed it, right, into some kind of database, a vector database or a vector store. Now, what happens when we assign such a query is that we retrieve context from the vector store so that we have more information provided to the LLM. So the LLM directly references the set of information provided rather than relying on its general knowledge. Now, this significantly reduces the likelihood of hallucinations and incorrect responses. And if the documentation doesn't have the answer, the LLM can simply reply that it doesn't really know, right, the answer to the user's query. So this is the most transparent way that we have that can and allow these LLMs to retrieve information in a more richer and fact-based manner, right? So that kind of gives us that first solution, right, into the whole limited domain knowledge limiter for deploying LLMs into the factory. Now let's look at the second item, right, which is latency and security constraints. So when we talk about AI infrastructure, Gen AI infrastructure, it really matters on what we are trying to achieve. So when we talk about office productivity, latency is usually not some concern. But on the factory floor, latency can become a process constraint, right? So that's the first thing that we always consider when it comes to what kind of solution we're going to deploy. The second driver is our IP and data, right? So factory data has a lot of sensitive information, whether it's our recipes, our process signatures, configurations, customer information, and so on, right? So a lot of organizations are uncomfortable with the thought of pushing that information to an external environment. So now the question becomes, where do we place inferencing, right? And where do we keep our data? So this is where the trade-off comes between cloud, on-prem, and edge, right? So cloud gives you the most flexibility when it comes to heavy batch analytics, training, or some use cases where you require a lot of inferencing power, right? But cloud loses on latency, network dependency, and data-related concerns. Now, on-prem is usually the middle ground. It's the more practical solution, so you improve IP control, but you still have to share your information to a central location. These are usually your on-prem or on-site data center, right? And scaling can be slower. Edge now is really interesting because it puts the model physically very close to the tool, right? Or at least within a plant boundary, right? That gives you the best latency and the strongest privacy posture. And it's especially relevant when you need an AI solution that like reacts to alarms or events, right? So finding the infrastructure solution that works best for you is really going to depend on your use case, right? So I'm not saying that everything goes to the edge. I think the best designs are typically hybrid, right? Where we have edge for low latency inferencing, event handling, sensitive context, on-prem for vector stores, for example, and cloud for maybe the non-sensitive data aggregation or experimentation or model training, right? So you now have to figure out the best place to place your solution. So now let's talk about the edge, right? Because that's a very interesting application, which is how do you squeeze everything that I just showed you into a single edge device? And doing that actually gives us a lot of flexibility in terms of what kinds of solutions we can deploy to the factory floor. Now, how do you squeeze, right, everything that I showed you into a single edge device? So the answer comes down to really first understanding model size, right? The typical assumption is that bigger is better, right? But the model size actually can influence three practical things, right? The reasoning capability, computational demands, and deployability. So there's no real standard definition of what makes a large model large or medium or small. So these are just generic statements or sizes that I typically use. So when we're talking about large, these are tens to hundreds of billions of parameters trained. So these are models that are really great at general reasoning. They have extremely good language fluency. They can handle ambiguity and so on, but they require more memory and more computing power, right? And they increase latency. So small and language models give us some advantages in terms of the lower latency, right? And they are often very relevant for manufacturing, since many many of many of our tasks are often bounded, right? A lot of manufacturing problems are not open-ended, creative writing kind of solutions, right? They are often about classification, extraction, summarization, and so on. So when you just pair a smaller model with retrieval, you can actually get a model that is that has a high accuracy, and the RAG allows you to kind of narrow that reasoning burden down, right? So let's look at it, right? So we've had quite a lot of success in using small or medium language models into a single edge device. In this case, we used an AI PC. There are two concepts here that are very important, right? When you're trying to build an entire LLM within a single edge device. One is quantization, and the next is hardware acceleration. Quantization, if I could define it, it's really that when models are trained, they are trained using very high precision, right? Now, that's good for training. You need a stable model, but it's very expensive, right, when it comes to inferencing. So quantization basically optimizes or reduces the model weights to a lower precision level. So now that allows the model to sit in a much smaller footprint. It allows faster inferencing, lower power consumption, right? So that's the first thing you need to do, right? Quantize your model. The second is really, like I said, using some kind of hardware acceleration, right? So many of the AI PCs today include NPUs or neural processing units, and this helps to handle the AI-related workloads, right? So you can keep your CPU running without interfering with your CPU workloads or also your GPU-related resources. So now just doing these two steps would allow you to kind of utilize a medium language model in a single edge device. You kind of take away that whole concerns about latency and IP and security, right? And these are easily flexible and scale solutions that can be deployed into specific applications, bounded applications in manufacturing. Right, so we talked about the first two, right? Now the third one, how do we move beyond just chatting, right? Beyond conversational into something that is able to make decisions, take actions within the factory floor, right? So that's where this whole concept comes in about agentic AI, right? So it's been a buzzword for the last year at least. But still, I've observed that many manufacturers are still within the early stages, right? So most of their efforts around LLMs are concentrated in very generic productivity cases that are very task specific, right? That has very high level of human involvement. A human basically enters a prompt and gets a response. Now, the real value in these LLM use cases is if we move further up the curve, right, and adopt some of these agentic AI methods where agents are more integrated into our operational data engineering systems and execution platforms, right? And that allows us to move from being more task specific to goal oriented, right? Having more autonomy and using more reasoning capability. And the numbers show that there is this gradual move, right? That we see more enterprise software adopting agentic AI methods, right? And I'll kind of describe what that means to us. So when we think about agentic AI, it's really the first question is what does being goal-oriented bias, right? So now the first thing is when you look at most of the applications in manufacturing, it's really a single task that needs to be accomplished, right? What we really intend to do, if you think back of the examples that I showed you in the previous slide, right? Say the example of wanting to write a shift report. It's not about accomplishing one single task, right, that you could do with a single prompt. It's about something that requires you to get from point A all the way to point B, right, from start to end. that's multi-step, right? There's many steps involved, many ifs and whats and buts and that we need to consider, right, in order to accomplish that end goal. So the first thing about agentic AI is that it allows you to go from a single task to something that is more multi-step, heading towards a goal. Second is that when you move from step to step, it's about retaining memory, right? State retention. So step 2 needs to know what step 1 did and carry that memory with it, right? So that it can accomplish its task. And step 3 needs to know what the previous memories did, previous steps did, right? And finally, you need access to tools, right? Many times just being able to summarize is not enough, right? So we may need a tool. So for example, if you're doing that shift report example again, you may need a calculator, right? So that you could do math, so you could calculate the exact quantities of weight movement within your factory. Now, so these three qualities are what can be enabled through agentic workflow. So these goes beyond what you could see from just using these LLMs as conversational tools. So let's do an example right here. So something that we are all familiar with, something that as manufacturers we do frequently, right? Which is troubleshooting an equipment. Well, first we kind of look at it as what would a human do, right? When it comes to equipment troubleshooting. So as a human technician, I would have to observe an alarm or an error code and then document some information like what time it happened, what product or lot or equipment configuration it was, look at the logs, refer to my SOPs or manuals or technical manuals, and then start the diagnosis and troubleshooting process, right? So there's a number of steps that we would typically do as human technicians and operators. Now, how do we convert that to an agentic flow, right? So we're moving from an LLM that answers questions to an LLM-based system that executes a workflow. The process that I would typically use is really kind of putting them side by side, right? So how a human executed the task next to how would an agentic AI workflow do the same, right? So the first thing is on observation. So that's talking about a listener, right? Some kind of event listener that knows that is aware of its environment. Documenting information, that's all about context, right? What was the context for that alarm? Checking logs and service manuals, that's all about retrieval. And finally, about reasoning and triage, right? That's about taking action. What should be the suitable action? So we can kind of try to build a simple agentic flow using this kind of building blocks, right? So it's not so agentic AI, if you look at it from this perspective, it's not so much about building an AI model, but it's more about system design, right? It's about trying to accomplish in an automated fashion the workflow that a human would typically do. So let's look at these 4 blocks and how we could break it down into agentic AI application, right? So the same 4 blocks that I mentioned, an event listener could be a watcher, right? They watch for triggers, alarm codes, transitions, SPC violations, and so on. And the concept here is that the agentic workflow is not going to be user prompt driven, right? So it's going to be event driven. So when it detects that there are certain events that requires it to kick into action, then that's the purpose of the listener here. Next is context building, right? So that's critical, right? So what it needs to do is construct the minimal but sufficient context packet that contains things like the tool ID, recipe, timestamps, and so on, and that you can use in order to accurately build your next step. So again, we are talking about memory. We're talking about moving from one step to the other while retaining the important information, right? So the right context will ensure that you don't have a garbage in, garbage out kind of solution. Document retrieval, that's the RAG layer. So you have to do your chunking, embedding, vector search so that you can find the most relevant passage from your manuals SOPs. And this is really the step that anchors the LLM, right? In evidence, in the sources of truth. And this is the step that reduces the hallucination risk. And finally, we have a reasoning and triage, right? Where we use all the context, the retrieved evidence, so that we can classify the issue and propose what are the suggested checks and actions that the human needs to do. So you can see within this type of agentic application, it's more linear. It goes from step to step, and the LLM does the final reasoning and triage, right? So this is one example where it's a relatively simple agentic workflow that can be implemented in manufacturing. And you notice that the human is still in this loop, right? So the LLM stops at the point where it does the reasoning and triage, but the human ultimately does the execution of the troubleshooting. We can still rearrange this, right? So the way there's many ways we can architect this solution. So now I'm using the same 4 components here, but I've changed the interaction mechanism, right? So, and here I'm introducing a new concept, which is the LLM orchestrator, right? And which is really important for scaling. So now what practically this means is that we have an LLM that now has a stronger understanding of its objective, right? So it's not just doing a summarization based on all the context that it's provided, but it's actually going to, since it understands the objective, which is to provide the right reasoning and triage for a human troubleshooter to proceed with his work, it's now able to kind of decide on what is the tools and steps that it needs to do to get to that objective. So for example, it could practically call a log query tool so that it pulls the last 50 alarms. It could call an MES API to get the history and recipe. It does to call a vector search to look for the right manual and so on. So now you give it much more autonomy to kind of decide what kind of rules or what kind of searches it needs to do in order to accomplish its objective. So you can see this, it is basically the same application, but we have architected it in 2 ways within the 2 slides, right? The first one is basically a much more linear application. The second one is a much a more autonomous application with some enforced guardrails, right? So it really depends on where we would like to design our solution for. So that kind of brings me to this last kind of my closing point here when it comes to agentic solutions is that, remember, we talked about these 3 complex workflows, memory, and tools. The 4th one is really about autonomy, right? Autonomy gets a lot of attention when it comes to external solutions that are not in the manufacturing context, right? So a lot of, you'd see a lot of ads or videos online about building fully autonomous applications, letting your factory run autonomously. My personal view is that you'd want to do this with some level of caution, right? So there's this whole spectrum, right, of going from applications that have very little autonomy towards more autonomy. And sometimes we get the case or questions on which is better, right? There's really no one answer. So, but my rule of thumb is that it's a lot easier to build less autonomous applications, right? And when you think about it, it's more suitable for when we have clear step-by-step processes or SOPs, right? And applications that require more autonomy are those that where you don't know the steps ahead of time or you need more reasoning capability. The interesting thing about manufacturing is that, well, we have a lot of SOPs, don't we? Right? So we have a lot of step-by-step processes. So in fact, I would say, and I would argue that many manufacturing use cases would likely need less autonomy, right? And that's a good thing, right? You could get a strong ROI even if you develop applications with less autonomy. You can deploy it sooner. It's easier to validate. It's easier to build trust. And once you have done with that, then you can so gradually expand autonomy, right? When it's safe and it's justified. So for manufacturing, although it's not as kind of attractive as highly autonomous applications, I think our goals personally are always operational reliability and safety, right? So autonomy for us is more of a design choice. So just keep that in mind when you're thinking about your solutions. All right, so I'm almost going to wrap up. So now putting all that information together, right? What I've learned over the past of working with this technology is that LLMs really do have a practical role in the factory floor, but the value comes when you have targeted use cases, right? That's the very key takeaway. You need to have the right use cases, and you need to marry that with the right solution design, right? The second one is that area domain experts need to be very deeply involved, so that we define the use case, we validate the output, and encode real world constraints, especially around safety and reliability, right? The second key takeaway that I have is that LLMs don't replace your existing AI analytics and automation solutions. As manufacturers, we have deployed many of those over the years. These don't go away, right? But where we see LLMs being abundant is in roles that are complementary, right? So it would allow us to use those tools and automation systems more effectively. And the third one is that we should start small, right? So I showed you kind of the steps involved, start small, well-bounded pilots, and then gradually scale up, right? When it comes to things like autonomy and so on, those are not things you want to attempt at the first go, right? So to think about fulfilling your use case before experimenting with greater autonomous applications. All right, so yeah, so that's the sharing today. Hopefully that was some useful guidelines for some of us who are getting started with LLMs in our manufacturing. Yeah, and you can always connect with me, and we can talk about this topic further, right? There's only so much we can talk about in this 25 minutes, but hopefully this is enough, right, to get many of us who have not really applied this technology in manufacturing to get started.
Yeah, thank you very much, Michael, for the very fine presentation. And so we're not over yet. We still have our Q&A segment. So I'll ask a couple of questions myself, and then we'll go to the audience Q&A. So as mentioned, do put those questions in the Q&A box, and it's good to see we have quite a few already coming in for Michael, which shows, I think, the degree of interest in this topic of LLMs in manufacturing. So a couple of things occurred to me, Michael, as you were going through your presentation. One is that given all the hype and perhaps noise around AI and LLMs as well, what would you say are some of the common misunderstandings that manufacturers may have about the applicability and the potential of LLMs in their facilities?
Okay, so common misunderstandings, right? So yeah, so I think I see this a lot, right? So number one is that I think there's some misunderstanding that LLMs like understands your processes or understands the physics behind your manufacturing, right?
Right.
So they don't, right? LLMs generate language and not truth, right? So that's the grounding principle, right? And I think that's really important because that emphasizes the need of doing bounded solutions for whatever you're going to deploy into manufacturing, right? And that's where I started with kind of explaining about how do you optimize your LLMs so that it has a better understanding of your sources of truth that is meaningful for your operations, right? So RAGs are really important, and that's really how we reduce the tendency for fabrication, right? That's one misunderstanding. The second one is that more data can give you better results. I think just dumping in a lot of data and hoping, or a lot of documents into your RAG and hoping that gives you much better inferencing, that's also not true. I think what bad data just produces is that it produces LLMs that are a lot more confident of the nonsense that they spew, right? So that's
Right.
another thing to be cautious about. So
Okay.
we need to ensure we have the right amount of data to train, to either train the model or as part of the context building, right? That's the second one. And then maybe the last one is about autonomy, right? So I've heard statements like LLMs can run the factory. No, I don't think they are at that level of maturity, right? So we have to think of it as decision support tools and not as control systems or fully autonomous systems at this stage of the game, at least.
This stage, right.
Yeah.
And okay, thanks. Very, very good points there, Michael. So, and as you know, there are an increasing number of commercially available large language models. So, I wonder how important, or perhaps not important, is the selection of which LLM to use in your application?
Okay, I think the LLM itself, the model itself, to me is less important than the data and the
Right.
architecture, right? The the most important thing is that we need models to be paired with good retrieval, like the good data sources from the factory. We need the right guardrails. We need to focus on the domain context, right? So these are fundamental. The models itself, you don't need the latest and greatest trillion parameter model for most manufacturing applications. In fact, many of our use cases, since they're so bounded, right? So we are talking about very specific documents, SOPs, and so on. So we as manufacturing, we can actually benefit from just utilizing very small models or medium-sized models that are bounded to strong, good data and context, right? And that actually allows us to scale much faster, much more cost effectively, right? Rather than paying for high-end models that have this amazing background in general knowledge, and but it's not applicable for our use cases.
Okay, thanks, Mike. And let me go to the questions now because I see we have quite a number of those coming in. A question here about the type of PC. So, if we plan to use an AI-enabled PC on the shop floor to assist operators, what type of PC would be suitable? Um, what type of PC would be suitable?
Okay, so I think many modern AI PCs would be able to carry a decently sized medium-sized language model, right? So the important thing is the methods that I outlined earlier, having that doing quantization. So and if you have an Intel AI PC, it comes with OpenVINO that allows you to do the quantization for you. And another thing to consider is having an NPU, right? So many of the use cases, again, I don't think we require, for example, a heavy workload GPU for it, right? So the NPU allows you to kind of free up that resources from your GPU as well. So look for an AI PC that has an NPU that has sufficient memory in order to build this, in order for you to kind of fit your medium-sized model within its memory footprint, right?
Right,
No
okay.
specific one, but I think there's lots of options today in the market.
Right, okay. And I think you did touch on this issue, but here the question is asking, what are the major differences in terms of the capabilities of an AI solution that's deployed on the cloud, on-prem, or right at the edge?
Okay, you could deploy anywhere, right? But I think it's more about trying to find the solution that best fits your use case, right? So you could deploy everything in the cloud, but again, that's where you may start to be limited by data latency, or you may be concerned about is it can I place my customer information on the cloud, right, without their permission, right? So there's lots of factors that we as manufacturers need to consider as part of our architecture design. So
Right.
edge solutions kind of give us the most flexibility. In fact, because many of the manufacturing targeted solutions, right? So as long as we are not talking about like automating the entire factory operations, right? We are talking about really targeted applications. So think about the application that I showed you just now. If you are thinking about an agentic application to help triage alarms before a technician actually goes and starts troubleshooting, right? So that perhaps saves that technician about maybe 20 minutes of per alarm, right? Let's throw that number out there. So let's say 20 minutes an alarm, right? And that particular application does not need the full inferencing power of a cloud solution, right? It basically is something that could really easily reside within an edge or as an on-prem solution. So think about your solution before kind of deciding where to deploy it, right? And
Right.
from experience, edge and on-prem solutions can help us in many of our manufacturing related problems, right? So yeah,
Right.
that's where I would look at it.
Okay. And and here we have a question from Andreas Spanner. And he's asking whether you would recommend an AI platform which comprises models, RAG, context, and prompts versus a single deployment and operations approach for AI capabilities. So platform versus a single deployment.
Again, I think it's going to be depending on your use case.
Right.
So I personally, I've done a lot of targeted use cases, and so it's always been standalone use cases for specific applications. And I've seen a lot of success that way, right? Versus trying to build one huge platform that houses multiple solutions. So that was my approach. But yeah, I think there are many enterprise solutions as well being marketed out there, right? That we can also potentially leverage. It just depends on, again, what problem are we trying to solve, right? Yeah, so I think there are many things that we can do on our own without having these third-party applications. But again, it depends on the maturity of your organization, what kind of data you have, what kind of infrastructure you have, and so on.
Right. Okay. Okay. And we've had a couple of questions on the same theme, I would say, about the use of AI versus humans and the return on investment, and how do you quantify the benefits of using the type of approach that you've been talking about against the traditional use of humans in manufacturing, and beyond that, once you have your solution, do you need additional human efforts to make it work? Is what the questioner is asking also.
Yeah, I think to me this is another tool in our toolbox, right? So it's not the only solution, but it's something that we
Right.
can keep in mind, right? That it's available to us, right? The technology is here, and it's something that we can apply to solve problems, right? Many of the solutions that I've developed actually took up very little cost, right, in terms of developing. As more models get deployed, the cost of the tokens cost for each prompt is also kind of reducing. So even if you use a foundational model that's in the cloud, it's not as expensive as what it was. And if you kind of use a model that is more small or medium and put it on an edge device, you even eliminate the need of that cost of each prompt that goes in as well, right? So there's many ways we can do these applications in a way that's very cost effective, that does not require some really fancy infrastructure around it. So I see it as just another
Okay.
tool, right? Another tool, just as we use let's say statistical analysis tools, right, as part of our
Right.
manufacturing
Right.
problem solving, right? So this is
Sure.
just another tool that we have
Okay.
that we can use.
Okay.
Mhm.
Okay. Right. Yeah. So a question here from Pascal, and he agrees with you that contextualization is indeed critical, but he wants you to explain a bit more about what challenges you may have faced when it comes to contextualization, and how did you overcome these challenges?
Okay, so actually this is the so a lot of times when we start people usually want to jump to the solution, right? It's like go build a solution. But um before we talk about building the solution, the first question is always about what data do we have, right? That provides context towards the solution that we are building, right? And a lot of times it's very difficult to find the right data, right? So a lot of information is tribal, right? So it's information that users have kind of acquired over the years, right? So, like for example, the equipment troubleshooting one, right? So, we have technicians that have worked for many years that kind of have this knowledge kind of built in, right? So they have this knowledge and it's passed down to their successors and other operators, but it's not documented, right? So the first part is really retrieving all the right documentation, right? And making sure that it's up to date, making sure that it's really true, that it's relevant, that it's factual, um, because that becomes the context for whatever solution you're building, right? And what I found is that is the most difficult part because a lot of times our sources of truth are not well documented, right? So anytime we are going to start a new project, the first question is always, do we have the right data, right? Do we have the right documents? Do we have the right specs? Do we have the right manuals in place? And only when we can answer that, right, can we talk about building a solution, right? So if we don't have the right context, we can build a solution, but again, it's just going to spew untruths, right, versus anything useful.
Okay, okay. Okay, another question. When deploying LLMs in the factory environment, how should companies plan the number and size of LLM instances relative to the number of operators or daily queries? So in terms of your capacity, size of your LLM, could you take a stab at that, Michael?
Okay, I don't think that is typically the constraints, right? See, when we use RAGs especially, um, what we are doing is helping provide kind of doing a intelligent search of our entire knowledge base, right? So we are finding uh, um, the specific context for the application that we are doing, right? So that in itself minimizes how much we provide to the LLM in order to summarize or analyze or infer. from, right? So what
Mm,
I think is that that is rarely the bottleneck, right? That the part that what information gets channeled to the LLM.
right.
That doesn't usually does not contain like millions of pages of context, right? It's very
Mm,
targeted, it's very concise. So that
right.
itself ensures that your pipeline is not going to be fully overloaded, right? So
Right.
I don't think that what you've asked is really a concern. It's most
Right.
likely it's not, right? Unless you are doing prompting with the entire manual all the time, right? And that's why I always suggested building a RAG, right? Building your vector
Mm,
database first,
mm,
right? As a first step, gathering your documents, identifying your knowledge base, building a vector database. These are your foundational steps, right? And
right.
once you get that done, then we talk about the building and application around it, right? Yeah,
Mm, mm.
so as long as we do those steps, I don't think we are going to be very bandwidth constrained or anything towards the LLM.
Okay. We do have a couple of questions about the issue of domain experts and domain knowledge, which you talked about in your presentation. One is about is there an issue of human bias going into the model from those experts, and also um, there could be a threat that those domain experts may feel, my own job is at risk here if I contribute to this initiative. So how would you get over those kinds of issues?
Okay. So yeah, I think when we talk about these LLM based solutions, especially the agentic AI kind of solutions, I think we need to position them as co-pilots, right? So the way we kind of deploy this is that first we need to do the right branding, right? When we are deploying it to the factory floor. Any change is usually something that people feel uneasy about, right? And there's a lot of fear or unease when it comes to AI, right? Many people look at it as a something that would replace them. So
Mm,
I think it's really important that we position LLMs as these co-pilots, right? So
mm,
we still need our domain experts, right? But we need them to act differently, right? So now instead of uh, being these sources of truth, right, that they keep internally to them, now these domain experts need to become content owners or reviewers or trainers of
mm,
the system, right?
mm,
And we need to be really explicit that at the end of the day, the final decision rests with them, right? So
mm,
there are very few. In fact, I'm not really aware of any, but I could be wrong, of fully
mm.
autonomous agentic AI systems that's running any key
Right.
manufacturing system, right? So I
Okay.
think so we have to be realistic that what we have today
Mm,
is something that can act as a co-pilot, something that can help save our
mm.
time and improve our decision quality and
Right.
allow us to make fewer mistakes. But
Mm,
ultimately, the final decision is with humans, right? So we as humans, we as engineers,
mm.
technicians, or operators still have a role to play within this context.
Mm, right, right. We are running out of time. I'll just say this very last question because you are from the semicon industry, and we have a very specific question. It's about, have you had a chance to explore Semikong, the 2024 open source LLM designed specifically for the semiconductor industry? Is that something you're familiar with, Michael? Semikong?
No, so I have not explored that. So yeah, so maybe something I should. So
Right. Okay,
yeah, but
okay.
I'm sorry, I have not.
Sure, sure. Okay, okay. Yeah, I mean, there's a lot of questions that I'm very grateful that people have taken the time to put in today. And unfortunately, we don't have time to go through all of them, but we will keep a record of these questions and get those to you and hopefully get some of those answered. But given the time constraints right now, for me, I want to thank you very much, Michael, for not only your fine presentation, the first time we've been looking at generative AI for our Asia webinars, and very fascinating topic of LLMs and their applicability in manufacturing. And yeah, so thank you for that, and also for your patience in going through all the very many questions that we had today. And for now, let me hand back to my colleague, Thavarajah, ARC India, for the closing.
Right, thank you.
Thank you, Bob, and thank you, Michael, for that insightful presentation. I also appreciate our delegates' active participation as well. Just some quick updates. Our next ARC Asia Industry Insight event will be announced soon. We have our upcoming ARC Asia Industry Forum starting in Tokyo, Japan on 7 July 2026, followed by Bangalore, India on 9th and 10 July 2026, and Singapore event on 27th August 2026. We have our Europe Forum scheduled for 4th to 6th May in Spain. We also had our Orlando Forum, which was done on 9th to 12th Feb 2026. As we conclude, I would like to thank Michael Thavarajah, Principal Engineer, Intel Corporation, for participating in the ARC Asia Industry Insight webinar. We also would like to thank Bob Gill from ARC Advisory Group for moderating the session, and we also like to thank all the delegates for participation in this webinar. Finally, we thank ARC Advisory Group India team for all the logistic support. Thank you all once again. Thank you, Michael, and thank you, Bob.